that's when you will find it. So we're trying to find the area of this shape. So looking at this shape carefully now, watch this, right? We got this over here is 18. If I take this line all the way across like this, right till here, I can see that that length over there is going to be 6. So that means this top length over here will be 12.
Oh, 12.
Because together it has to add up to 18. It's got to add up to 18. See, there's 18. It's 18 all the way across here. So let's move this whole thing over here. And you can see that's going to be there, which is going to be 18. I mean 12, and this is going to be 6. Because this stays 6 all the way through. The height of it stays 6 all the way through right over there. So now when you bring it all the way through here, you can see that that's going to be at the top there, 12 centimeters. Okay, so you can see that. Now let's go to the bottom one. So that one is 12. Let me just move it closer. This bottom one over here, we do exactly the same thing. Look at the longest side. You can see this side is short because it stops there, right?
Mm-hmm.
So that means if I had to go further, how much further would I have to go? And that's where I've got to look at it and say, okay, well, if I had the entire line drawn like this, and I brought it all the way up like that, it's 12, 12, 12, 12, 12, 12, 12, 12. What will this number be on this side if that line is 12? It will have to be 4 centimeters, and this is not drawn to scale, right? This is way longer than 12, and it looks like it's probably just not, it's not the right size, right? Not exactly the same size, but 8 plus 4 is 12. Can you see that?
Yeah.
So this becomes 4 centimeters as well, because that is that number there. Can you see that?
Yeah.
So now I have both sides lengths. I have, let me just erase that, and this is going to be 4 centimeters now. Now I want to calculate the area for this. I can break it up into 2 rectangles. Okay. If I break it up into 2 rectangles, I'm going to have that rectangle and I'm going to have that rectangle there. Now I must look out very carefully. This rectangle can either be 12 times 8 or it can be 18 times 8. Which one do you think it is? 12 times 8 or 18 times 8? 12 is too short, right? So it'll have to be 18. So that's incorrect. The answer is 18 times 8 because we're looking at the entire space. The 12 stops here, doesn't go further. But the 18 goes all the way down. And the 8 goes all the way this way. So length times breadth. 18 times 8. I'm going to grab a calculator quickly. 18 times 8 is 144. So that gets me 144 centimeters squared. 144 centimeters squared for that area. Then you got this one here, which is 4 times 6. 4 times 6 is not, this one you can either write 12 times 6, right? Or you can write 4 times 6. Now you won't write 12 times 6 because 12 is going over the green line. You don't want the 12. The 12 goes too far. You want to go length until there. And the only length is that one there, which is 4. Because that's 4, that means this is also 4. This small part is also 4. So 12 times 6 is out. 4 times 6 is my length times my width. And 4 times 6 is going to get me 24, right? So that's going to be 24 centimeters squared. And now all I've got to do is add the two areas together. And my final area, or my area total, is going to be equal to 144 plus 24. 144 plus 24 is going to be 144 plus 24 comes to 168. Yeah, 168 centimeters squared, and we found our solution. But now there's another way of solving this. There's another way of solving this as well. So let's call this one method 1. Another way of solving this is if I use maybe a different selection of triangles. Let's say, I mean rectangles. Let's say I use this area of a rectangle, roughly, and then this area of a rectangle. And if I calculate each of these, the dimensions are going to change accordingly. This now is going to be 8 times 12. If I do that, this one here is going to be 12 times 6. So it covers the whole area. But it should come to the same answer. This is going to be 96, and this is going to be 72. And when you add those two up, you'll also get to 168. So that's also fine. And then the third possibility of working out this area is if I calculate the whole area, imagine there's a big block here, and I minus this area. So if I take the big area, that area, and I subtract this area is going to be 12 times 4. You can see that, right? This is 12 times 4, because it's simply just that length times that length, and that's going to be 48. I got 48 centimeters squared. And then I've got this length over here, which is 18 times 12, and that's the big area. All right, that's the bigger area. So if I got the big area, what am I actually doing? I'm removing that area, and what I'm going to be left with is the L. If I subtract it, if I minus it, right? I'm minusing big area by missing small area. I've got the missing small area now. The big area is going to be 12 times 18. So the entire big area, which is this whole space from there to there to there, all the way around, that is 12 times 18. And what is 12 times 18? 216, right? That's 216 centimeters squared. So the big area is going to be 216, and the small area is 48. So we minus it. So we take 216 minus 48, and we get 168 as well. All right, 168, 216 minus 48 comes to, let me just make sure. Yeah, 168 centimeters squared. So there's 3 ways of working that one out. Okay, that's L-shaped composite